Okie dokie. In this notes, we are going to be talking about what's called experimental probability. So label that at the top. Last time we talked about probability is the chance that something happens. And here I put our little chart to help us remember that if it's a 0, that means definitely not going to happen. 1% to 49% means it's unlikely to happen. It could, but most likely won't. A 50% chance means it's equally likely or not likely to happen. Then anything up to 99% is likely. It could still not happen, but it most likely will. And then 100% probability means that it's definitely going to happen. Okay? Last time we talked about theoretical probability. So when I'm thinking about the chance of a coin landing on heads or tails, okay, it has a 1 in 2 chance of landing on heads, a 1 in 2 chance of landing on tails. Okay, it's pretty even. It's exactly even. But experimental probability is what actually happens. Okay, not what should happen, but what does happen. So we would expect that when we flip a coin, half the time it lands on heads and the other half it lands on tails. But it doesn't have to each time. So the probability of whatever event we want, so the probability of heads, would be the number of successes divided by the number of times we tried it, so the number of experiments we did. Okay? So right here, this table shows us the result of rolling a die 50 times. So in this column, I have the number that was rolled. So a die has numbers 1 through 6 on it. And this bottom row is how many times that number got rolled. So for instance, this one right here, when they rolled a die, they got 1. When they rolled it, landed on 1 10 times. That's what frequency means. How many times did that happen? Okay. So what is the theoretical probability of rolling a 3? So the probability of a 3 equals, well, it's out of 6 because there's 6 sides to a die. And there's only 1 3 on that die, so it's a 1 in 6 chance, which is 0.166 repeating, which is 16.6 repeating percent. I prefer the fraction way. That's easier for me to decode rather than the decimals. Okay, so that's what I expect to happen. Every 1 out of 6 rolls, it will land on a 3. But according to this table, what is the experimental probability of rolling a 3? So the probability of a 3, right here, so here's the number I rolled. We rolled it 8 times, and it was out of 50 trials. So 8 out of 50. Let's practice reducing. I can divide those both by 2. Gives me 4 out of 25. So 4 out of 25. 4 divided by 25 is 0.16, is 16%. So hey, that was pretty close to what I expected to happen. Okay. What is the experimental probability of rolling an odd number? Well, let's highlight all the odd numbers. Here I have 1, 3, and 5. If I add up the number of times those occur, I have 10 plus 8 plus 11 gives me 29 times. So the probability of an odd was 29 out, I didn't write a 9. 29 out of 50, which would be 29 divided by 50 is 0.58, which is 58%. Okay. Alright, this one. A bag contains 50 marbles. You randomly draw a marble, record the color, then put it back in the bag. The table shows the result after 30 draws. What is the experimental probability of pulling a red? Well, the probability of red is, they got it 9 times out of 30. We can reduce that by 3. Gives me 3/10, which is 0.3, which is 30%. Okay, so the probability of pulling a red marble is 30%. Something else we can do with experimental probability is predict the numbers of the total things. Okay, so the bag contains 50 marbles, but they only did 30 draws. So we can predict how many red marbles are in the bag. So I'm going to take my probability of red and multiply it by the total number of marbles. So my probability was 3/10 times 50. Put it as a fraction over 1. 3 times 50 is 150 divided by 10. We expect there to be 15 red marbles in the bag. Okay. That is it for this one.